microbiome and why it's important. And so I want to ask you, just ask you guys a question. You can answer. What do you guys know about the gut? What do you know about the microbiome, the intestinal bacteria? What have you heard of it? Anybody? Yes.
That antibiotics mess it all up.
Yeah, we're going to talk about that tonight. Yeah, right. And you grew up like I did in the 60s and 70s where they would put people on antibiotics and leave them on it for years. You remember that? Yeah, I remember that.
Yeah.
Go
My
ahead.
mother-in-law was an RN, and she had them in a big jar. She'd get them just about inexpensively.
Yeah, they put teenagers with acne on antibiotics and leave them on for years. What do you think that did to their intestine? That was before we knew all of this. We knew any of this. What else do you know about gut bacteria in the gut? Anybody?
It makes vitamin K.
Yeah, good for you. Yeah, it makes vitamins. Yeah, more than that, but that's very good. Yeah.
I ain't the only one.
So let's talk about it. What is dysbiosis? I use that term a lot in the office. It's an imbalance in the quantity, quality, or diversity of microorganisms in the gut. It could be due to any of the following: increase or decrease in commensal or good bacteria, loss of protective microbes, presence of unwanted bacteria, and imbalanced environment. So give me one thing that might create an imbalanced environment in the GI tract. Anybody?
Wheat.
What?
Wheat.
Could, yeah, could diet. Yeah, wheat for some people for sure. Anybody else?
Alcohol.
What?
Regular sugars.
Yeah, like our diet, sugar, alcohol. Yeah,
Like the artificial stuff they put in foods, like preservatives and
yeah.
that sort of thing.
Artificials. Yeah, red dye number 3.
Yeah.
Yeah,
Yeah,
right.
that's what it is.
Exactly. So our microbiome, our gut, contains trillions of microorganisms. Most of them are non-pathologic, but we do have pathologic bacteria in our gut, and they're important. And if we didn't have them, it wouldn't be good. So we do have pathological bacteria. They're just kept at a minimum. Now, I think they're there because they train our immune system. That's my opinion, okay? So the microbiome actually functions as an organ, and it functions synergistically with our bodies to protect against pathogenic invasion and colonization. It also, like Terry just said, provides vitamins and nutrients to the host while assisting with energy and nutrient extraction. So when we eat, if we have a right microbiome, a normal microbiome, it actually helps extract energy out of the food for our bodies. So what would that say about somebody with chronic fatigue syndrome, or someone that's tired all the time? Maybe it could be a gut microbiome problem. Now, it may not be. It could be a thyroid issue, an adrenal issue, a blood sugar issue, but it could also be a problem with the microbiome. So what are the causes of dysbiosis? Well, we've talked about them already. A high sugar, high seed oil fat diet, okay? Now, we just gone through the holidays, and I talked to several people. I know none of you did, but several people who ate too much sugar over the holidays, okay? You know, and a lot of those people came in and they weren't feeling very good. They were sick, all right? That really screws up the microbiome. And, you know, carrying around a lot of inflammation, which could also come from the diet, toxicity, like toxic exposures. I've talked about this before. We're constantly exposed to toxicity like plastics and things like that gets in our food, and that can affect our gut microbiome. Emulsifiers. What's the number one place? I'm gonna show you this later, but I'll get to it now. The number one thing that people use on a regular basis that has emulsifiers in it. Anybody?
Microwave?
No. Well, No, microwave just heats things up. What's the number one product, household product, personal care product that people use every day that contains emulsifiers?
Shampoo?
Shampoo does, yeah, but toothpaste.
Oh.
That's why I don't ever use toothpaste, never. I brush my teeth, just so you know that, but I don't use toothpaste. So a low fiber diet is a cause of dysbiosis. As we said, antibiotic use, certain pharmaceuticals. I think, this is again my opinion, I think most pharmaceuticals that people take disrupt the gut microbiome. We know that certain pharmaceuticals do, but I'm thinking that most pharmaceuticals do. Loss of neonatal exposure, I mean, the way that you're born can matter. We'll talk about that later. Sometimes you just have a genetic predisposition for an imbalanced gut microbiome, and just general pathogens that we're exposed to on a regular basis. Now, if you look at the general population, 40% of the microbiome that we have is shared with half the population. So that means 60% is unique to us, all right? So our microbiome is as unique as how we look. For this 40% would be the core. So what gives us our special microbiome? Well, you know, the family we grew up in, the way that we eat, the way that our family ate, the way that we lived, the stress in our lives. But the thing is that when you look at the microbiome in terms of its correlation with disease, it's pretty difficult sometimes to correlate somebody's microbiome with the disease that they have, because there's so much differentiation when it comes to this. Genetic influences, diet, lifestyle, they all play key roles in our microbiome. So it starts with our mother. And when we're going through the birth canal, that's when babies get inoculated with the flora that they need to build their gut. So when C-section babies don't get that. So some doctors that are smart, that are really on top of this, when they deliver C-section, they go in and scrape the vaginal canal of mother and put it into the baby's mouth so the baby can get the gut bacteria, begin producing the bacteria that they need. Otherwise, they don't get that. What do they get then if they don't do that? What do they get from a C-section in a hospital? What kind of bacteria do they get? How about all the nasty bacteria running around in the hospital, okay?
Yeah.
Which they shouldn't be getting. By the way, if you look up the amount of people that die from nosocomial infections every year, hospital infections, anybody know what that figure is? 75 to 100,000 people die, go into a hospital and die from hospital infection. You can look it up, okay? Would you say that's a lot of people? Yeah, you know, and here's the interesting, I was thinking about this one time. If one person gets hurt badly in a chiropractic clinic, which happens about every 4 years, that makes national news. One person. But 75 to 100,000 people die every year from hospital infections. They go in the hospital, they get an infection, they die. Did anybody know that? No. Okay. So when a C-section baby is delivered, they're not getting the mother's bacteria, which they really need. They're getting all the bacteria from around the hospital, a lot of which isn't good for people, okay? So oral dysbiosis is common, and a high sugar diet. So this is dysbiosis of the mouth. And then here's where we talk about commercial toothpaste, detergents, and emulsifiers strip away many protective microbes and allow other organisms to populate. So what happens when other organisms populate our mouth?
It upsets the natural microbiome.
And what's the result of that?
Illness.
What kind of illness? Like, how about cavities?
Oh.
Things like
Yes.
that, bad breath, you
If
know?
we're talking about our mouth.
Yeah, our mouth, right. So our mouth, we have bacteria in our mouth. We're supposed to. they're not, our mouths aren't sterile. And so personally, as a toothpaste, I use baking soda. That's what I've used it forever. And I don't use any kind of toothpaste because of this, okay? Now, my wife has not followed in my footsteps. She likes her toothpaste, I'm not gonna argue with her, okay? So, but she can do that if she wants to, but I'm not going to. Okay, if you look at the population of the gut bacteria, you don't have a lot in the stomach, but if you go down here, you start following it down, you have an enormous amount of gut bacteria in our large colon, enormous amounts. Just a little bit in our stomach. As you go down, it gets more intense. And in the stomach, many of the incoming microbiomes are killed due to the pH of the stomach, which is really low. That's why a low pH of the stomach is good, because you need that low pH, that acidic pH, to break down protein, but it also kills pathogenic bacteria that we're exposed to, okay? So what would something like Prilosec or Nexium do then? What do those drugs do?
They turn off your protein pumps that are gonna give you the stomach acid that you need.
Yeah, they stop stomach acid production. So people that are on these drugs have a much higher probability of ingesting pathogenic bacteria that are not killed by stomach acid, okay? Along with just upsetting your microbiome in general. So the number of microbiomes in the stomach is 10,000 per mil compared to 10 million per mil in the large intestine. H. pylori is an important stomach bacteria. It functions as a microbial teacher, it trains the immune system, keeps the immune system in balance. What happens when H. pylori gets out of balance and we get too much of it?
Ulcers.
Yeah. The guy that figured that out won the Nobel Prize for that. Okay, H. pylori is actually our friend. We need it in our stomach. It acts as a protection against GERD and heartburn. It influences gastric hormones, which are needed for leptin and ghrelin release. These are the two hormones that regulate our appetite. Okay, so when they're out of balance, you can either have a huge appetite or no appetite. It's estimated that only 10% of all children have H. pylori in their stomachs. And why is that?
Because of diet?
Diet, terrible diet, and they give kids a lot of pharmaceuticals. How many kids take antibiotics regularly for colds and things like that? Children not colonized with H. pylori tend to be at increased risk for developing asthma and allergies. Okay, so here is an example of the concentration of bacteria. You can see as you go down into the GI tract, it just gets much more concentrated. So at any given time, our gut contains about 3.5 pounds of bacteria. It's the same weight of the liver. And the function of the gut bacteria is about as important as the liver. So bacteria in the gut have a lifespan of a few days to a few weeks. Approximately 500 billion bacteria per teaspoon in the GI tract of bacterial content. So what are the actions of beneficial gut bacteria? So they compete for micronutrients, which we get from our food, and binding locations in the gut. Okay, so who do they compete with? Anybody? What do they, the good bacteria are competing with the bad bacteria. Okay, so that's why if you don't have enough good bacteria, the bad bacteria tend to take over. They also produce antibiotics or natural antimicrobial secretions which target bad bacteria. They produce short chain fatty acids. That should be SCFA. didn't get that right, through fermentation. And they break down bile, okay, bile acids. Gallbladders are extremely important to human health. They produce bile. And bile is a very powerful natural antibiotic to the GI tract. In other words, it kills off pathogenic bacteria without hurting good bacteria. So people without gallbladders tend to have problems with dysbiosis. That's why anybody that comes into my office gets bile that doesn't have a gallbladder gets bile salts, and I tell them you got to stay on it for the rest of your life, because if you don't have a gallbladder, you need this, okay? And it's amazing how much better they feel once they start taking them. So here's typical good bacteria: bifidobacteria, lactobacillus, firmicutes, proteobacteria, actinobacteria. Disruptive bacteria is Campylobacter, Enterococcus, and everybody knows about C. diff, Clostridium difficile. What does that normally cause when somebody's got an overgrowth of that? Anybody? Diarrhea, bad diarrhea, okay? The good bacteria exist in a symbiotic relationship with the host. We have predominantly what are called gram-positive lactic acid producing bacteria, which are lactobacillus and bifidobacillus. Those are the bifido. These are the two primary bacteria. We have a lot more than this, but these are the two primary ones. Now, I want to show you something, and this is important. Lactic acid producing bacteria increase the bioavailability of minerals which require acid for absorption, like calcium, copper, iron, magnesium, and manganese. Without a healthy colony of gut bacteria, these minerals and other nutrients will be chronically depleted. Now, has anybody in here ever taken a product that I have called lactic acid yeast from me? You have, right? One person. Okay. This is why I give lactic acid yeast, for this very reason. It acidifies the colon, it provides lactic acid, and it helps absorb all of these minerals. It's not a yeast that produces a yeast infection, okay? It's an acid-producing yeast that produces lactic acid where you can absorb those minerals. So here's diversity. Which one of these, if these were bacteria, which one would have the best diversity? This one or this one? This one? Yeah. That's how your gut bacteria should look, not like this, okay? Now, another thing I want you to understand is the concept of biofilms. Biofilms are like apartment buildings for bacteria, okay? And they're very strong. They can be health or disease promoting, and they can contain multiple bacterial species. They're impervious to the immune system of the body, and they're impervious to antibiotics. It's really important because some of these bad bacteria will attract heavy metals. They'll kind of shack up together in a biofilm, and that creates disease in a human being. They're unaffected by antibiotics. Now, here's the good news is through specific herbal products that I carry, they can bust these biofilms down. But not all biofilms are bad. Some of them are good, okay? But a biofilm starts like this. It can form within a few minutes to a few hours. A biofilm will give off spores. They'll start to colonize, build another biofilm, and it starts all over again. So if you've got like chronic yeast infection in the body, this is what's happening. And that's got to be stopped. So let's look at yeasts live in biofilms, and chronic yeast infection are normally a biofilm issue. So biofilms are really important because a lot of bacteria are unable to survive without them. They're most commonly found along the mucosal barrier of the large intestine. although they can get in the skin, the eyes, urogenital tract, they can sense stress, and they can promote inflammation and inhibit nutrient absorption. So let's look at known biofilm pathogens: E. coli, H. pylori, C. diff, Pseudomonas, staph, strep, candida. These all can live in biofilms. And sometimes I have some particular products that are biofilm busters that can really handle things like this pretty well. So this is just a diagram that shows if this is the lining, the one cell lining of the intestinal tract, you have two different mucus barriers that most of your bacteria live in. And what happens with antibiotics and a bad diet, that decreases this barrier, and that's when pathogenic bacteria can cross this and get into your bloodstream and cause problems. So let's see. Okay, other bacterial responsibilities: produces vitamins, activation of certain food components such as lignans. A lignan is like an estrogenic compound found in food that doesn't act like estrogen, but your body treats it like what it just escaped me. I'll think about it in a minute. Okay, so lignans act like antioxidants. That's what I'm thinking of. They act just like antioxidants. Bacteria will convert drugs to bioactive forms, and the conversion of bile acids and xenobiotics to xenobiotic is like we'll just call it a pharmaceutical. It converts xenobiotics to products that aren't as harmful to the body. So this is an interesting study. This study, they did a study of they looked at a patient who took a week-long course of clindamycin, which is an antibiotic. And they did the bacterial diversity before they took it, and then they looked at it for 2 years out. And this was the biodiversity after 2 years. Does that look like that? No. So you see it really altered after just one course of antibiotics, really altered the biodiversity and for over 2 years. So antibiotics are not great for us, okay? I'm not saying they're not necessary at times. They're not great. What about probiotics? If 40% of the gut microbiome is common to all people, then 60% is unique. So probiotics don't work for everybody, okay? Because if you have 1,200 species of bacteria in your gut, and you have a probiotic with maybe 20, how do we know that that's the right thing for you? We don't, okay? That's why some probiotics make some people feel better, some people don't notice any change, some people become bloated, have discomfort, depending on the person's gut profile. Probiotics have been demonstrated to act like intestinal tourists. They change the gut flora as long as it's being taken. Then after 2 weeks, the change goes away. That's why I don't use probiotics. I'll tell you what I use here in a minute. Let's look at the relationship between dysbiosis and disease. This is probably the most important part of this talk. You have this gut-liver axis. So the liver receives 70% of its blood supply from the intestine via the portal vein. It's constantly exposed to metabolites and byproducts of your gut bacteria. So non-alcoholic fatty liver disease has been strongly correlated with bacterial overgrowth and dysbiosis. So if you don't eat a lot of sugar, which causes fatty liver, and you don't drink alcohol, which causes fatty liver, but you have a fatty liver, it's probably because you've got dysbiosis. And I think that's fascinating. So how does that occur? So imbalanced gut bacteria metabolizes dietary choline, which we get in our food. Reduced choline causes reduced levels of phosphatidylcholine, which is needed to clear triglycerides from the liver. Triglycerides are fat. Without phosphatidylcholine, you get a fatty liver. Then the phosphatidylcholine is metabolized by the gut bacteria into what's called TMA, which is trimethylamine, and that's transported to the liver, where the liver turns it into TMAO. Now, TMAO is a blood test that I do that correlates dysbiosis with heart disease. So TMAO, trimethylamine oxidase, is a known predictor of heart disease, and it's an excellent marker to measure heart disease risk, as well as a test for whether dysbiosis may be causing disease in the body. It contributes to hardening of the arteries, and now here's something really interesting. I want you to get this. Bacterial dysbiosis acts on L-carnitine and red meat to form TMAO. So how many of you have heard that red meat causes heart disease? Okay, no, it doesn't. It's dysbiosis, the bad bacteria in a gut acting on L-carnitine form TMAO, which causes a heart disease. So you can eat all the red meat you want if you don't have a dysbiotic gut. It's dysbiosis that's doing it, not the red meat. So dysbiosis is associated with irritable bowel disease. We don't know the exact mechanism, but it plays significant role in colitis and Crohn's. Patients who have dysbiosis that have these have decreased microbial populations, low diversity, and microbial instability. You have decreased firmicutes, increased bacteroides. These two have to be in a certain ratio, and when this ratio is imbalanced, that's when you get people that have weight issues and can't lose weight, okay? Other gut dysfunctions, IBS, celiac, and colorectal cancer are also implicated with dysbiosis, but no specific pattern has been determined. Obesity and type 2 diabetes are strongly influenced by altered gut bacteria. So if your blood sugar you can't get your blood sugar down no matter what you do, maybe a gut dysbiosis issue, okay? Incompletency, okay. Central nervous system disorders. There's a gut-brain axis, so we know that gut dysbiosis can result in cognitive and behavioral disorders. In pathogen-infected mice, Campylobacter jejuni, a common cause of food poisoning, can produce anxiety-like behavior. One of our major neurotransmitters, gamma-aminobutyric acid, can also be affected by gut bacteria, also affecting both your central nervous system and your enteric nervous system. So we can have gut-brain inflammation due to problems with gut bacteria, which can cause depression and psychological issues. Bifidobacteria infantis, which I don't know where you get that. I've never seen it. Supplementation has a positive impact on depression and mood. Just that one type of bacteria. So what are the strategies for bloating and GERD and any dysbiotic issues? Now, I always start with upper digestion and gallbladder. I give bile salts for people that don't have a gallbladder. You can really help your digestion just with bitters. You know, what you can get those at a liquor store. Okay, they're real cheap. I used to sell them here, but I thought I could send people to Trader Joe's and they get them a lot cheaper than I can sell them. So I stopped carrying them. So you just put some bitters in some water and drink it down before you eat. Really stimulates digestion. You know, a good hydrochloric acid supplement and pancreatic enzyme can really help with digesting food. Now I have what's called a GI Flora Balance program. It's a weed and feed. So I try and feed the gut bacteria, weed out bad bacteria with certain herbs and products, followed by seeding or feeding good bacteria. It says minimum of 6 months. I usually go like 3 to 6 months of doing this. Okay, and I've had really pretty good results with this. Occasionally, GI dysfunction may require a combination of a gut healing protocol and stealth pathogen protocol. I've talked about stealth pathogens before. So sometimes it's a combination of that. But I don't, like I said, I don't use probiotics. I use a weeding and feeding program. And I found that that really helps the gut bacteria as much as anything that I've ever seen. Plus you have to change the diet. So I would say at this point, you know, who do you know that has GI issues that isn't being helped? That you know, they just keep taking one pharmaceutical after another. This is something that really might be able to help them. You might want to just have me talk to them and check them out and see whether we can help them. So I'm going to show you a little test that I do to be able to tell whether somebody's gut is not working, or it's working or not working. Who wants to volunteer? Anybody? Come on up. Okay. Face your public. Pull this arm out. Resist me. Okay, I'm just going to see whether you're testable. Resist. Yeah, you're good and testable. Okay. So what I do is I just take the gut. Resist me. And just twist it a little bit. And hers is working fairly decent. Okay.
Better than it was 3 months ago.
Yeah, better than it was 3 months ago. So that's a test that I do. And that, if that weakens the arm, there's a problem there. And doesn't tell me what it is, doesn't tell me if there's a biofilm or anything like that. It just tells me there's a problem and we need to work on it. So, any questions about anything I've gone over tonight? No?
There's a lot.
Clear as mud, right? Yeah, okay. All right. No question. Was it too much material or?
Not if I can get the slides.
Okay. Everybody looks a little overwhelmed, maybe.
There was
Big
a
words.
quote that you said that you recommend.
Bitters?
No.
Not that one?
Oh, I thought there was something else. Yeah.
Oh, sorry.
Okay.
That was it.
Any other questions?
So how do you know if you have a problem?
Number one is symptoms. You know, do you have symptoms? Have you been diagnosed with a fatty liver? Do you have symptoms of any GI issues? Chronic immune dysfunction? Anything like that would be a, you know, have you ever gone to a foreign country, you know, gotten Montezuma's revenge or food poisoning and never quite been the same? That would be a definite indicator that there's a
It
problem.
was at an army post, it wasn't that from the Korean food I ate.
Oh, okay. All right. And you know, some people, if you have a strong microbiome, you know, your body can handle that and come back to balance. I was in Haiti back in the 80s, and I got really bad food poisoning there. And you know, I tended to balance out after a while, and I was fine after that. I never had any long-term issues, but a lot of people do.
Is bloating or other digestive issues a symptom?
Could be, absolutely, yeah, could be. You may have bloating, you may not have enough stomach acid, you may need pancreatic enzymes, you may not have complete dysbiosis, you know, we just need to,
Little,
Yeah.
Yeah.
yeah, but it could be dysbiosis, yeah. I'd like to do a case history and find out how long have you had it, when did you get it, at what point were you well and then you got sick? You know, those are all really important things to find out. Yeah. Okay, Terry.
By taking fish oil, does that increase your digestive ability, and does it make you sleep better at night?
Fish oil helps your brain quite a bit. Yeah, it helps your
I've
cells.
been taking it, it's really been, really been good.
It's not what I would give for dysbiosis, but it's good to take it.
Okay.
Yeah, really good. Yeah.
I take it with my vitamins, so.
Yeah, good.
Yeah.
Okay, great. We're a little bit later tonight. Thank you so much for coming. What are we going to do in 2 weeks?
The importance of the nervous system.
The importance of the nervous system in health and disease. So, if there's no other questions. Thank you for braving the our poll.